I'm Anil Kumar, and here is part B of question number 16, page 129 from Nelson, Vectors and Calculus. Consider displacement function s of t equals to t cube divided by t square plus 1, where t is greater than or equal to 0. What happens to the velocity and acceleration for very large value of t? So let's find the derivatives for the displacement. So we know s of t, that is the displacement, is equals to t cube over t square plus 1. So velocity is derivative of displacement, so that is equals to displacement derivative. We'll apply the quotient rule to find this derivative. So we have t square plus 1 whole square in the denominator. Derivative of t cube is 3t square times t square plus 1 minus t cube times derivative, which is 2t for the denominator. We can simplify this. So we'll just multiply 3t square with t square. You get 3t to the power of 4 plus 3t square minus 2t to the power of 4 divided by t square plus 1 whole square. Now the numerator is t to the power of 4 plus 3t square divided by t square plus 1 to the power of 4. Now we need to find what happens to the velocity and acceleration for very large value of t. It really means that, now this is the expression for velocity. If t is very large, that means we need to find limit of the function v of t when t approaches infinity. Do you see that? Now, so that means we need to find limit of this function as t approaches infinity. So that is the question, right? Now as you can see here, degree of numerator is t to the power of 4, and for the denominator, this is t square, and for the denominator it is also t to the power of 4, right? So same degrees for numerator and denominator, and therefore it is ratio of the leading coefficients. So it basically approaches t to the power of 4 over t to the power of 4, which is 1. So what we find here is that the velocity v of t approaches 1 as t approaches infinity, right? So that is how we can find this answer. Now let's do acceleration part. So for acceleration we find derivative of the velocity function. Acceleration is equals to v dash t. That is, we'll use this particular function. So we have square of the denominator, which is t square plus 1 whole square makes it 4. Derivative of numerator, which is 4t cube plus 6t times the denominator t square plus 1 whole square minus numerator, which is t to the power of 4 plus 3t square times derivative of denominator, which is 2 times t square plus 1 times 2t, right? Derivative of inside function, 2t, right? So let me rewrite this. Let me push it a bit here. So we have acceleration as equals to all this. I could take t square plus 1 common, and we can actually factor this also, 2t from here. So we can take 2t times t square plus 1 common in the numerators. So if I take 2 times t from here, I'm left with 2t plus 6 divided by 2 is 3 times t square plus 1. We have taken t square plus 1 outside, so from square we are left with this. And here we have taken 2t as a common factor, so we have 2, and then t square plus 1 we have taken as a common factor times t to the power of 4 plus 3t square. divided by t square plus 1 to the power of 4, right? Now, in this particular function, let me do one more steps, and then t square plus 1. Here, if we expand, we get 2t times t square plus 1, which is 2t cube, plus 2t, 3 times plus 3t square, plus 3, and minus 2t to the power of 4, minus 6t square, divided by t square plus 1 to the power of 4. So if you multiply t's, then what is the degree of the numerator? I'm not simplifying it, but I'm just saying inside degree here is 3. 3 times 3 plus 2 is 5. 5 plus 1 is 6. And degree in the denominator is 8, right? Now since degree of numerator, we say degree of numerator is 6 and degree of denominator is 8. What happens to limit as t approaches infinity for a of t? Can you tell me that? Since the degree of denominator is much higher, the function actually is kind of 1 over t square, right? So it approaches kind of, right? So it approaches 0. So we can conclude from here that for large values of t, acceleration approaches 0. And we found that the velocity approaches 1, correct? So that is how we could solve this question. I hope that helps. Thank you and all the best.